Oh, divided by
V is equal to IR.
influencer.
So we know that we have to use that formula, V equals IR, right? And what's our V?
Voltage.
110, and our total resistance was 55. So we just divide
110 by 55.
to get our total current. So that's pretty simple in a series. The T just stands for total.
Oh, okay.
So you add them and divide in a series.
Correct.
Okay.
It's the parallel.
And so in series, we know that current is the same at every point, right? If I ask you what's the current at R1, it's going to be 2. What's the current at R3? It's still going to be 2. So how do we find the individual resistance at R1? We know the total, but how do we find the individual resistance at R1? It's right there, it's 10. Okay. And if I asked you what is the voltage at resistor 1, how would you get that answer?
110 equals I times 10. And then divide by 10.
Oh, sorry. So we have to find the voltage at resistor 1, right? So don't worry about the 110 right now, because that's our total voltage. We're trying to find the individual voltage at R1. So how would you find that?
Using amp and the resistor.
So we would take the 10 ohms from resistor 1,
2 for
and then we already know our current, right? Which is what?
2.
2. And then we just plug it into our formula. So the question is asking you, what is the voltage across resistor 1? It's not asking you for the total voltage,
It's just asking him
that specific spot.
Which is 10.
Melanie?
I know.
No, it's not 10.
You said the resistance.
I said, what is the voltage at resistor 1? So, because it's asking for this specific point, we're only going to focus on this number right here. So we're gonna take our 10, and then what's our current? 2. 2 is the current at every spot in this circuit, right? So, yeah, it's going to be 2 at every spot, because that's what the answer was in our previous problem, when we found our total current. So we're gonna take the 2, which is our current, we're gonna take our resistance at R1, plug that in, right? And that's how we get our voltage at resistor 1. So if I ask you what is the total voltage, your answer is 110. If I ask you what is the individual voltage at R1, you would have to plug it in and the answer would be 20 volts. If I ask you what is the voltage at R2, what would you do?
30. 15 times
Or walk me through the steps.
2 multiplied by 15.
So we would take the 15, which is our resistance there. We would take the current, 2, and then multiply together, and our voltage would be 30 volts. Make sense?
So you're saying like the voltage at R2 is 30.
Correct.
But then, and now I'm just confused.
The current.
So the current at every spot is 2. It's going to be the same. Okay?
That's my question. Alright, gotcha.
The voltage is not going to be the same at every single spot, because this is a series circuit. Yes.
But they add up to the 110.
Correct.
Okay.
So if you find the individual voltage at R1, R2, and R3, all those numbers should add up to 110.
So 20, 30, 60.
Is anyone lost?
No.
And then with parallel circuits, what was the rule? Voltage is the same at every spot. Okay. So now it's asking you, what is the total resistance in the circuit? How do we add up resistance in a parallel circuit? Do we just add the numbers like normal?
No.
No, it's inverse, right?
Yes.
So you would have to do 1/4 plus 1/4. that we have to have the common denominator. So you do 4 times 3 to get to 12, and then 3 times 4 to get to 12. And whatever you do to that bottom number, you would do it to the top number as well. That's how I got 3 over 12 plus 4 over 12. So then our resistance would be 12, our total resistance. Do I need to explain that again? Brady, you good?
Let me take a picture of it.
Okay.
I think this would probably.
Yeah, I have some worksheets for y'all.
Thank you.
So if I asked you, what is the voltage at resistor 1? 12. What about resistor 2? Because it's gonna be the same since it's a parallel circuit.
Ma'am, this is not the end. Resistance is not 12, it's 12 by 7. The next step that you have the next step. Yes,
Oh,
ma'am.
sorry. So 1 over RT equals 7 over 12, right? Because we added 3 plus 4. 7 over 12. And so in order to solve for RT, you would just divide both sides by 7. And your total resistance would be 1.71.
Thank you, Shane.
What can I explain again?
So I guess seeing it side by side is confusing. So it's that 7 and 12, that's like 7.
7 over 12.
I thought you only divided by the denominator.
You cross multiply it.
So, do you understand where I got this 7 over 12 from?
Yeah,
Mhm.
from the very end.
So right now it's saying 1 over RT equals 7 over 12. So I just cross multiplied and rewrote this thing as this. So 7 RT equals 12. And so I want to get RT by itself, so what would I do?
Okay,
I divided both sides by 7, which gave me this answer.
this is like I need to see.
Right.
Yeah, so that's what the yeah.
Okay. So, how would we answer this question? What is the current at resistor 1?
Yes.
V is equal to IR. R we know is equal to 12.
Well, first of all, what is our voltage at resistor 1? 12. And do we know our resistance at resistor 1? Which is 4. No, it already told you the answer. It's 4. When you try to add the resistance to find the total resistance, that's when you do 1 over R. 4.
Oh, can you go back, please? Thank you.
So now the current
So-
is different at every resistance. state.
Yes, because we have a parallel circuit, so we know that the current is not going to be the same at every single spot. So we just use that V equals IR. V is 12, because in a parallel circuit, the voltage is the same, correct? And then we got our 4 ohms from resistor 1, so we just plug that in, and that would give you your current at resistor 1, which is 3 amps. You would do the same process to find the current at resistor 2. You would use the 12 volts and the 3 ohms as the resistance. Okay? Alright.
Quick question.
Yes.
What if the question asks, what is the voltage of resistance 1? R1, resistance R1?
What is the voltage at resistor 1?
Uh-huh.
It would be 12, because in a parallel circuit, the voltage is the same everywhere.
Oh, okay. So we could fill in those blanks where it says V1 and V2 is 12?
Yes. Alright, so that was series and parallel. Now it's going to get a little confusing.
What?
combination of both parallel and series circuit. So in order to solve for these kinds of problems, you have to first, figure out which one is the parallel and which one is the series. Okay, so notice that, which one is our parallel circuit in here?
State square equal voltage. Which one for? The ones that are stacked?
R1 and R2 are parallel, right?
Oh, yeah, cause it's two.
Cause it's two separate, wires, okay?
So would 3 and 4 be parallel?
Also parallel. Take a look at R1 here and R2. They're two different wires, right? So they both are parallel. R3 and R4 are also parallel, okay? So, how would we calculate the total resistance of R1 and R2?
1 over R1 plus 1 over
Okay, so we would do 1 over 100 plus 1 over 250. And what's our next step?
And then you do the same for the bottom one, ma'am?
We have to find the common
Oh,
denominator.
I see.
So 250 and 100 both go into 500. Okay, 250 times 2 will give you 500. 100 times 5 would give you 500. So you would do the same thing to the top numbers, which would give you 5.
7.
Why did I say 300?
Is it, no, it's just a 5. 250.
It should say 5 over 500, not 5 over 300. And you just add that, two numbers, 5 plus 7. So that's our total resistance at 1 and 2.
You mean 5 plus
5 plus 2, 7 over 500. Are y'all confused? Carla, you good? Okay. So our resistance would be 500 over 7, 71.43 ohms. So our total resistance here is 71.43.
And that value is gonna be different because the one underneath it, R3 and R4, is 350 and 200,
Yes.
right?
And
So
then
you
you
had a
going
question?
back to the.
Yeah, so when we put in the calculator, do we do like 7 divided by 500 or 500 divided by 7?
So, right now it's 1 over R
Uh-huh,
equals 7 over 500.
okay.
So you just have to cross multiply and flip the answer to say this.
R
So you would do 1 over R is equal to 7 over 500 and then cross multiply?
Yeah, you should do it here.
Okay.
He's like,
Yeah, I-
It's just the inverse, yeah.
Yeah, you just flip the answer.
1 over.
What does it say,
Because
1 over?
1 over R is the. it's
7
not the
over?
same.
Can you use
Fine.
this one right here?
That is R over 1.
You can look over
7
here.
hours is equal to 500.
Let's talk about your marker.
oh, Jesus.
Oh! John's got the, what's it called?
OBJ.
He's saying.
What's that mean?
So 1 over R equals 7 over 500, right?
Yes, sir.
We want to get R by itself, so what would you do?
7 hours is equal to 500.
Multiply.
Cross multiply.
7 hours.
Okay, I see.
7 hours equals 500.
Yeah, yeah, go.
Oh,
Divide
okay.
R by
by
7.
500 by 7.
What's my answer? 71.43.
That's fine.
Are you recording me?
No, I'm recording the board.
Oh. Does that make sense?
Yes.
Okay.
So we do the reciprocal.
You know, you recorded the whole time up there.
I wouldn't be up close.
She didn't consent for that.
So, how would you find the total resistance for R3 and R4?
The same way.
Same way.
And then R.
350 and 200 both go into 1400.
Common denominator?
Common denominator.
Oh, and then 11 is the.
Maybe.
Like, there was a smaller common.
So now we know the total resistance for 3 and 4. Right? So now that we solved for the parallel parts, now we can treat this as a series circuit
But now again, oh, so now that's really a series.
because we know the totals, okay?
So we can add them up.
So the total resistance, how can you find it now?
Add them.
Exactly, yeah.
That's about the only thing I know.
So the total resistance across the board here would be 198.7 ohms. No, because now this is a series circuit. We already figured out the individual resistance for the parallel circuits. So now that we have the totals, we can treat it as a series circuit.
So you only do that one over anything when it's a
When
period.
it's parallel, yes.
Monia, can you go to the other slide?
The back, the one that was behind this,
Yeah, I think it was the one before. One more. One more.
So if this one had like another parallel circuit, you'd have to find that one and then add them?
yes, you would do 1 over whatever number plus 1 over the other number. Okay.
Hold on, don't change. Please don't. Oh,
Oh, no. Make sure y'all pay attention to how you solve this one, cause it could confuse you on the test. Let me know when I can move on.
okay, you can.
Why can't we take a picture of the one before this? This gives away.
We'll go ahead and take it. Alright, so now that we solved for the resistance at both parallel circuits, we have a whole different number, right? We can now treat this like a series circuit. So if I asked you, how do we calculate the total current, what would you do?
Current is the
Everything
same
together and
everywhere,
divide
or
the
V is equal to
voltage.
IR, so I is equal to V by R.
So we know that our total resistance is 198.7 and our total voltage is 24.
And we divide the voltage by that 198.60, right?
So we would plug that into our formula, V equals IR. We already know what V is, 24. We know what R is, 198.7. So we would divide 24 by 198.7 to get our total current, which is 0.12 amps. Okay?
And because you treat it like a series, that's gonna be the same
Yes,
for both.
so 0.12 here, 0.12 here. Because in series, the current is the same,
It's same.
okay? But what if I asked you, what is the current at R1?
You just multiply
100.
that point 12 times, that's.
So now I'm not asking you for the total current, I'm asking you for the current at R1. So now it's asking you about that one specific section, so we have to break it apart into that parallel circuit again. So Johns, tell me, what would you do? It's asking you for the current at R1. Any idea?
Nope.
Okay, so
V is equal to IR.
in order to find the current at R1, you have to know the individual voltage at R1.
So
So that's one divided, no.
So, what we would do to find that voltage is we would take the current, which we know is the same here, right? In both sections, 0.12, multiply with our resistance, which is 71.43, to get our voltage here.
And what is the current?
Okay, I'll explain again. So we're asking you to find the current at R1, right?
Okay.
In order to find the current in this section here, have to find the individual voltage. You can't just use this one, but that's a parallel circuit, okay? So how do we find the voltage in this specific area?
Yeah, take the numbers,
What numbers would you use?
the resistance total above.
The resistance and our current, 0.12.
So the point 12 is given?
The point twelve came
No, we
from
found
where?
it in our earlier problem,
Oh.
remember?
Oh, Lord, we gotta go back.
Yes.
Right before.
So now
It's
you're
gonna be a
finding the
lot of
current
going
of
back.
the both
Okay, I'm
circuit
gonna
current.
guess.
Oh, I see.
That's very cool.
Got it.
Yeah, that's the fastest
Finding
option.
that is
Just guess.
difficult.
There were 25% chance.
So how do we get this 0.12?
So you
This-
added
The total resistance is
Resistance.
adding both of these. And the voltage, total voltage is right there, total resistance is adding both of those, and then you find the I from there.
Yeah.
So you divided that total
Now
voltage,
it's-
voltage got a total resistance.
Hold on. Okay,
Oh,
Emily, how do you think we found the total
I need to
current?
think.
When you just add the two resistance.
So we added the two resistance, which gave us 198.7, right? And then we already know our total voltage, cause it's right there. So we
Mhm.
plug the numbers in, our total current is 0.12, okay?
Mhm.
So that means the current here and here is 0.12, okay?
Cause now it's a series and it's.
Correct. But now the question is asking you, what is the current at R1? Not the total current, the specific current at R1, okay? So in order to find that specific number, we can't just use,
The total voltage you
the
can.
total voltage.
Which type is it divided into?
So we would have to use the current here, which is 0.12, right? And then we would have to use that total resistance,
Okay.
okay? Multiply those two together, that would give you the voltage in this section.
Mhm.
Then you have
Okay.
voltage and resistance, and then you can just find the current.
So now that we know the voltage at R1, we can use our V equals IR formula again to find our individual current. So we know our individual voltage is 8.57, and what is the resistance at R1? 100. So you divide both sides by 100. 0.86 amps is your current at R1.
Can you go back a slide real quick? How you found 0.12?
0.12. We used our formula, V equals IR.
Uh-huh.
What's our V?
So why did you do, you divided 24 by 198.7?
Okay, first of all, tell me, how did I get 198.7?
You added those two?
Okay, and then we're trying to find the total current, right? So what is our formula?
V equals IR.
And what's our V,
Voltage,
which is?
24.
And then what's our total resistance?
198.7.
So we would divide both sides by
190, or
198.7,
we will divide both sides by 24.
To isolate that.
not 24. So right now it says 24 equals I times 198.7.
Uh-huh.
So how would you get I by itself?
Divide both sides by I.
190.
Oh,
I
190.
divide by 0.
So that's why it says 24 divided by 198.7.
Because I did it the other way. I did
Cross multiply.
divide both sides by I.
You want
No,
I as
that's
you divide by,
Oh.
I divide by 0, then one.
That makes sense.
Yeah, so if you want to get I by itself, you need to divide both sides by the other number next to it.
Mhm.
And that's how we got our total current, which is
0.12.
0.12 amps. Okay? Melanie is done with her life. Alright, so we know that the total current is R1, is 0.12, right? So are you gonna answer me, the current at R1 is 0.12?
No.
No. Cause this is a, what kind of circuit?
Parallel.
So can it be the same?
No.
No, so your answer would not be 0.12 amps. That's why, in order to find the current in this section here, you have to first find the individual voltage there, okay? And how do we find the voltage here?
So take the 0.12 amps that you have, and you will multiply it by the resistance in that
In that
parallel
section, and that would give you the voltage.
Yes.
So the voltage at R1 is 8.57. What about the voltage at R2?
It's the same.
It's the same,
Same.
because it's a parallel circuit, okay?
So the voltage is the same resistance.
Yes.
So we don't have the current, so we're finding the current basically.
Yes, in order to find the current here, you have to first find the voltage in that area, which is 8.57. Now that we know the voltage, we just plug that into our formula, right?
Yes.
R1 is 100, because it's right there. Divide both sides by 100, and your current is 0.86 amps, right here. So what would you do if I asked you what is the current here?
It's the same because.
8.57.
Voltage is 8.57, because it's gonna be the same since it's parallel. Divide both sides by 250, your current would be 0.34 amps. Now, if you want to check your work, if you add 0.86 and 0.34, it should give you 0.12, which is the total current.
Because
Y'all okay? Anyone confused?
I've been
Sorry, not sorry.
Okay,
So now
Yes,
what
sorry.
changed, ma'am?
I'm not confused. I just
Okay.
need to recap
She
it.
say work.
Okay.
Okay.
When
For
is
a
the
series-
vote?
Hold on.
right, for a series parallel combination circuit, correct? To first you need to find the total resistance, right? And that's the whole,
1 over R.
yeah, and find the least common denominator, and then cross multiplying and dividing to get the total voltage.
Total resistance.
Total resistance, I'm sorry, and you got the total resistance, right?
Yes.
Then you divide, the voltage, that 24, by the total resistance to get the total current, right?
Correct.
Then you multiply the total current by the total resistance, right?
Mhm.
To
And
get the
individual
individual
current.
current.
Mhm.
Then you divide the individual current by each individual circuit, right? To get the individual voltage, to get the individual,
No, to find the individual current, you have to first find the individual voltage
Voltage.
in those circuits.
and then,
Woke you up.
so you divide the 8.57 volts by the individual resistance to get the individual current.
Correct.
If you add the currents back together, you should get the total current.
Yes.
Okay. It's a lot of,
Shaheen, you good?
I don't know, if I work out a problem, maybe I
Yes.
would not,
Trust me,
you know.
once you do it on paper, it'll stick better than me explaining it.
both my hands are red, I'm so tired.
We should make it fit the target.
That's right. Buddy, you had a.
Oh my lord.
No, hold the alarm just so you can forget. You put an alarm, right?
yeah. Yeah, I get it. Yeah.
How did you still forget?
I have to.
Did you turn off the alarm and later forget?
Yeah, I think I